Today we will discuss the IUPAC nomenclature of anhydride compounds. So these anhydride compounds are nothing but just the derivative of acidic compound. That means if we take two molecules of any acid like this way, RCOOH plus R, like this way, okay, two acids. Now if we apply heat in presence of phosphorus pentoxide, then what will happen? From these two acids, H2O will be removed and the product will be RC++O, then this O, C++O, R. So this is anhydride compound, okay, where you can see one oxygen atom is present between two carbon atoms, right? So we can also write this compound as R C++O, O, C++O, R, and this point carbon atoms present. Or else we also can write, you just say RCO group, two RCO groups are present. So we can write RCO whole 2, then this oxygen. Okay, so this is anhydride. Now come the IUPAC name. To find out the IUPAC nomenclature of anhydride compounds, there are two types of suffix present. Okay. The first one is oic anhydride. And the second one is carboxylic anhydride. Okay. Now let's take one example. Suppose the simplest anhydride, H C++O, O C++O, H. Here you can see one carbon atom present in the both side of this oxygen. Here also one, this side also one. So for one carbon atom, we know the root name is meth. Single bond is present between carbon and hydrogen, right? In this main chain, single bond is present. So this is alkane. So for alkane, we know the suffix is N, methane. Now this is anhydride. This anhydride is coming from an acid. So for acid, we know the suffix is oic, right? So methanoic. Then this one is anhydride. So methanoic anhydride. That is this oic anhydride. Now see, if we break the anhydride in this position, okay, and if we add here one OH and here H, then you can find out the acid. That one is HCOOH or HCOOH, that is methanoic acid or formic acid. That means this methanoic anhydride, we are getting it from methanoic acid. Okay. Now take another example. Suppose now you can see in the both side of this oxygen atom, two carbon atoms are present. 1, 2, 1, 2. Right? So for two carbon atom, we know the root name eth. Then single bonds are present between two carbon atoms. Right? So ethane. This anhydride we are getting from an acid. So for acid, we know the suffix is oic. So ethanoic. This is an anhydride compound, so ethanoic anhydride. Okay. Now, if you break this anhydride compound in this position, and if you add here one OH and here H. Then you can find out the acid from where this ethanoic acid is coming. You just see CH3COOH, CH3COOH. That is ethanoic acid. That means the ethanoic anhydride is coming from ethanoic acid. Now, this ethanoic anhydride, this is the IUPAC name. It has a common name, and that common name is acetic anhydride. Acetic anhydride. This is the common name. And this is the IUPAC name. Okay. Now say, in the previous case, the IUPAC name is methanoic anhydride. Right? Now it also has a common name. And that common name is formic anhydride. This is the common name. And this is the IUPAC name. Now take another example. CH3COO CH2CH3. Okay. Now you just see this is the oxygen atom. And one side 1, 2. 2 carbon atoms are present, and the another side 1, 2, 3. 3 carbon atoms are present. So for 2 carbon atoms we know ethane. For 3 carbon atoms we know propane. Right? So and in case of anhydride we know the suffix is oic anhydride. So here it will be ethanoic, propanoic. Now you just say alphabetically E come first, then pro. So P. So we will first write the eth, that is ethanoic, then propanoic, then anhydride. Now let's take another example. Okay. So here you can see this portion is cyclic group and this is the anhydride portion. In this cyclic portion 4 carbon atoms are present. 1, 2, 3, 4. So we can say this one is cyclobutane. And this anhydride portions are attached with this ring in 1 and 2 carbon atoms. Right? So here we can write cyclobutane, then 1, 2 di carboxylic anhydride. Carboxylic anhydride. Now the question is why here carboxylic anhydride? Now see, if you break this anhydride in this position and if you add here one OH and here H, then the acid you will get is double bond OH and double bond OH. Right? Then what is the name of this compound? Cyclobutane 1,2 dicarboxylic acid. 2 carboxylic groups are present here. Now from this acid you are getting this anhydride, right? So cyclobutane 1,2 dicarboxylic anhydride, the name of this compound. Okay. Now take another example. Suppose Okay. Now here you can see in this cyclic portion total 6 carbon atoms are present. So we can write cyclohexane. Then 1, 2, 3, 4, 5, 6. In 1 and 2 position this anhydride group is attached. So cyclohexane 1, 2 dicarboxylic anhydride. Why carboxylic anhydride? Again same reason. If you break this anhydride portion in this part, then if you add here OH and here H, then the acid you are getting is double bond OH, double bond OH. Right? So you can see cyclohexane 1, 2 dicarboxylic acid. 2 carboxylic groups are present in 1 and 2. So dicarboxylic acid. So from this carboxylic acid portion you are getting this anhydride. So this one is cyclohexane 1, 2 dicarboxylic, then anhydride. Okay. Thank you. Take another example. Now you just see here cyclic groups are present, and in between these two cyclic group anhydride groups are present, right? So this is in this cyclic portion 3 carbon atoms are present, right? 1, 2 and 3. Here also 1, 2, 3. So we can write it cyclopropane, then carboxylic anhydride. Why carboxylic anhydride? Obviously again if you break this portion, here if you add OH and here H, then you can get cyclopropane carboxylic acid. So from cyclopropane carboxylic acid you are getting this anhydride. So this one is carboxylic anhydride, cyclopropane. Now if you like this video, then please share this video and subscribe my channel. Thank you.